We have a circle with this equation and we want to know what its radius and centre is. So I'm first going to complete the square on the x terms. So I'm going to halve the 8 and subtract 4 squared. I'm then going to complete the square on the y terms. So I'm going to halve the minus 2 and take away the 1 squared. Collect up the like terms. So the minus 16 and the minus 1 will make minus 17, which I'm then going to add to the other side, so it becomes a plus 17. So I can now see the centre of the circle is 4, 1, and the radius of the circle is root 17. Part B says to determine the coordinates where the curve meets the coordinate axes. So I know it's going to meet the coordinate axes. So it's going to meet the x-axis when y is 0. And it's going to meet the y-axis when x is 0. So let's find when y is 0 first. So we'll take the equation. And we're going to make y 0. So the y squared will be 0 and the 2y will both be 0 as well. So we'll get x squared minus 8x is equal to 0. We'll factorise the x outside. And we'll find that either x is 0 or x is 8. So we've got the coordinates 0, 0, and 8, 0. Now to find when x is 0, so when it's going to intercept on the y-axis. So if I make the x bits be 0, I will just be left with the y squared minus 2y is equal to 0 from here. Factorise. And I find that either y is 0 or y is 2. So we get the coordinate 0, 0 and 0, 2. So these are the coordinates where the circle meets the coordinate axes. Part C says that the straight line AB is the diameter of the circle and PQ is perpendicular to AB. We need to calculate the coordinates of A and B. So quite a lot of information in this question now, so I'm going to draw a little sketch to help me picture what's exactly going on. Here's my coordinate axes. We've got our circle that's got a centre of 4, 1, which is roughly here, and a radius of root 17. We know it's passing through 0, 0 and 0, 2, and we know it's passing through 8, 0. We're told that the point Q, which is 8, 2, that's lying on the circle, so that's going to be here. Remember, this was 8 and this was 2, so the point 8, 2 is going to be here. So that's point Q. P was the centre of the circle. And we are now told that AB is a diameter and PQ is perpendicular to that. So here is PQ. And the diameter AB is perpendicular. So AB is my diameter here. And we want to work out what the coordinates of A and B are. Right, the way I'm going to do this, which is not necessarily the most efficient way, but it is a standard way, I'm going to work out the equation of the line AB because I know it's perpendicular to PQ. So I can work that out reasonably easily. And then I'm going to work out where that intersects with the circle. So the gradient of PQ. Change in y, divide by the change in x. So we'll have 2 take away 1 divided by 8 take away 4, which is 1/4. So that's the gradient of PQ, which means the gradient of AB is going to be the negative reciprocal of that. So that's going to be -4. I can now say y equals -4x plus c. And I know this line goes through point P, the centre of the circle. So I'm going to substitute the coordinates for 1 in here. So 1 is equal to -4 times 4 plus c. So 1 is equal to -16 plus c, so c is 17. And we've now got the equation of the line AB, which is y equals -4x plus 17. Now to do some simultaneous equations to work out where that intersects with the circle. Remember, this is the equation of the circle, so I'm going to substitute my straight line into the circle here and here. So I'll have x squared minus 8x. Then I've got the y squared, which is going to become the -4x plus 17 squared, minus 2 lots of the y is equal to 0. Right, being careful when I'm expanding those brackets. Then I've got the -4x squared, which is going to become a plus 16x squared. The -4x times 17 is 68. And then double that, so we've got -136x. The 17 squared is 289. Then we've got the minus 2 times the -4x, so we'll have a plus 8x. And the -2 times the 17 is -34. And all of that is going to equal 0. Collect up like terms. So we've got the 17x squared. We've got -136x. And then we've got the 289 minus 34, which is 255. All of these terms divide by 17 reasonably easily. Which is going to allow me to factorize. So either x is equal to 3 or x is equal to 5. And I can now substitute those back to get the y coordinates. So if I substitute 3 here, I get 5. So when x is 3, y is 5. And then if I substitute the 5 in here, so when x is 5, y is -3. And there we go. That's probably the normal way most people, I think, would approach part C of that question. There is a slightly more efficient way you can do it with vectors. If you'd like to see that method, then do ask me about that in class.